Welcome, Hornets, and thank you for participating today. Today, we're going to be taking a look at the worked out solutions to the review for Quizzle number 7. Quizzle number 7 covers all the way up to implicit differentiation, but does not include related rates. So please be aware related rates will be on the next Quizzle for next week. You'll notice in front of you I have a copy of the pretest that I gave everyone today and yesterday. So what we're going to do is we're going to take a look at number 1 and review. In order to determine whether f is differentiable at x equals 1, we have to have a situation where the two values are going to have the same beginning and end. So where one function ends, the other half has to begin. This is the idea of continuous. So I like to write continuous, and then I put my derivative, my equation, 3x squared plus ax plus 4, and I want to set it equal to 6x minus b at x equals 1. So wherever I have an x, I'm going to put in a 1, and I get 3 plus a plus 4 equals 6 minus b, which allows me to bring the a and the b over to find a plus b. Now that's my goal. That's what I'm going to try to find. And since this adds up to 7 and we bring it over, it's going to end up being negative 1. Now, please be aware, as I told everybody, I already created the question poorly because you only have to answer the question now. A plus b is negative 1. So be aware, I am going to show how I would do this if the question wasn't quite so hokey and I had come up with a better question. Because what we always want to do is then do our smooth portion, and the smooth portion is the derivative of this line. So 6x plus a has to equal 6 at x equaling 1, and when we plug it in, we get 6 plus a equals 6, and a equals 0. That means that our b value has to equal negative 1, and then we would find a plus b. Alrighty, let's go ahead and move to number 2. Number 2 is working with the implicit differentiation. So I'm looking at 2y, y prime. The cosine is going to give me a negative sine of x times y. But we have to then multiply following the chain rule with the derivative of the inside piece. So I take the derivative of x, leaving y alone, plus the derivative of y, which we call y prime, and it equals 1. I now have to distribute the negative sine xy to both of these terms. So that 2y y prime minus y sine xy minus x sine of xy, y prime equals 1. Now you'll notice I like to put the non-y primes up in the front, the y prime in the back, and I'm now going to move this piece here. So we now have 1 plus, and we have our x sine of xy, and it's going to equal our y prime times what's left, and you'll notice that I have this 2y minus the x sine xy. This is what we're going to divide, and it's going to go into the denominator over here. And this is my answer. So this is what we're looking for. 1 plus x sine xy all over 2y minus x sine xy, the quantity. This brings us to number 3. Let f of x equal 2x squared on the interval from 1 to 2. At what value of x does the average rate of change equal the derivative of f, or the instantaneous rate of change? So what I want to do is I'm going to first start by finding what is f of 4 minus f of 2 all over 4 minus 2. When I plug in the 4 here, I get 16 times 2 is 32 minus 2 divided by 2, and I end up with 30 divided by 2 equals 15. I'm now going to set that 15 equal to the instantaneous rate of change. That's 4x. Divide both sides by 4, and x must equal 15/4. This brings us to number 4. When I plug in the 0, I get the 4th root of 16 is 2, and 2 minus 2 is 0 divided by 0. Because I get 0 over 0, I immediately go to L'Hopital's rule. We take the derivative. Now, in order to do this, you're going to want to change it to 16 plus h to the 1/4 power. This will allow you to bring the 1/4 to the front and subtract 1. You end up with 1/4, 16 plus h to the minus 3/4 times the derivative of h, which is 1. We're now going to apply our limit as h approaches 0. When I plug the 0 in, you'll notice that I get 16 to the negative 3/4 power multiplied by 1/4. So we're going to tackle that power first. We're going to start by taking 1/4 of the 16, or the 16 to the 1/4 power to be more specific. Since 16 is 2 to the 4th, and the 1/4 power multiplied by the 4th power will give us 2 to the 1st. So the 4th root of 16 is 2. We then work with the numerator, which is the 3. Then we'll multiply by negative 1 as a power. So when I take 2 to the 3rd power, you'll notice that I end up getting 8. The negative becomes 1/8, and I now multiply that 1/8 times 1/4, and my answer is 1/32. Don't let these problems give you an issue. They're not that bad. We just have to follow our steps and go slowly to avoid any mistakes. Number 5. In this problem, what we need to do is we need to take the derivative. Now, I'm hiding what we're working with. We're actually working with the natural log for the square root of 1 minus x squared. But written in exponential form, this is a lot easier because we know that the natural log brings our 1 minus x squared to the denominator. We multiply by the derivative of the inside, which is negative 2x, and we multiply it by the 1/2 out in front. Notice in this that the 2's are canceling, leaving me with negative x over 1 minus x squared. This is our derivative. That's what we're looking for. This brings us to number 6. Now, please remember, this is one of our obscure rules where we have log base a of u, and the derivative in terms of x is going to be 1 over the natural log of a times u prime. And that u prime is actually going to go into the numerator. So as we do this, please take note. Our a is the 2, so we have the natural log of 2 multiplied by 5x times the derivative of 5, the derivative of x. The 5's will reduce, and I'm looking at 1 over x ln of 2. That's my derivative. I'm going to give you a hint. Tomorrow's test, you're going to see the derivative of a to the u. You're welcome. Alrighty, that is part 1 for our pre-test. I hope this has helped, and I will be shortly doing part 2, which will be the second side of our pre-test. Alrighty, thank you very much, Hornets. I hope this has helped, and please remember to be kind to each other. Thank you very much, and bye-bye.